We want to solve a system of two equations and two unknowns by using the elimination method. Now, the elimination method works to where you're going to multiply one equation or sometimes both equations by something. You're going to add them together and you're going to get a variable to drop out. So the equation that you choose doesn't matter, and the variable you want to eliminate doesn't matter either. You're trying to find what would be the easiest variable to cancel out with. So what you do is you look at the two numbers on the x's and the y's, and you're trying to find the least common multiple with each of these. And that's what you're going to try and make both of these into. For instance, if I wanted to look at the x's, I have a 2 and a 5. So the least common multiple would just be 10. And ideally, you want to make one of them positive and one of them negative. And you're going to add the equations together so that way you get a variable to cancel out. So I have, if I do like a -5 times the first row and a 2 times the second row, I'm going to get -10 and 10. So that's one way I could do that. Now it's going to be the second one. If I want to eliminate the y's, this is what I would have to look at here. The least common multiple between 6 and 3 is actually just going to be 6. So this one already has the least common multiple I'm looking for. So it's probably going to be easier on this equation, these set of equations, to eliminate the y. So that's what I'm going to do. I'm going to take the first equation exactly the way it's written here. But then what I want to do is I'm going to multiply this by 2. But I'm not going to do anything with the bottom set of equations. Okay, because if I multiply this by 2, I get a 6y. So that way when I add these equations together, I can cancel it out. I don't even need to multiply by negative because this is already negative here. So I get 4x plus 6y equals -8 when I multiply. Remember to multiply everything through by 2, including the number on the right-hand side. Then I have 5x minus 6y equals -37. From here, you're just going to add the equations together. And by adding that together, notice that you get the y's to cancel, which is the whole idea. You get 9x, that cancels. And then you have -8 and -37. Add that together, and you're going to get -45 for that. All right, so now we're going to divide both sides by 9, and we get x is equal to -5. Okay, so now we have one of our answers, but remember these kind of systems, you need to get a coordinate for your answer. We now need to put this back into either equation. It doesn't matter. We can use the first one or the second one. I'll use the first one here. So we're going to do 2 times -5 plus 3y equals -4. And I get -10 plus 3y equals -4. And I'm solving for y. And so I need to add 10 to both sides there. And we get +6. Then divide both sides by 3. And we get y equals 2. So therefore, when you write your answer, you write it as a coordinate. We have to put the x value first. So you're going to do -5, 2. And that's how you would do something like this with elimination. Now, suppose that we don't have it as easy as this one. This one was easier because the least common multiple was already found. Well, what if you don't have that in each one? We're going to look at an example next to where we don't have that same kind of situation happening. Okay, so this one here, we have a 3 and a 5 and a 4 and a 3. So in this case, my least common multiple is not going to be the numbers that I see displayed here. So I have a choice whether to solve for the x's or the y's. So since I just solved for y in the last problem, let's go for x this time. So if we want to solve for x, we want to find the least common multiple between 3 and 5. Now that's going to be 15. That's the smallest number that both 3 and 5 divide into evenly. So 15 we're going to make here. However, we need to make one of them positive and one of them negative. So the first equation, I'm going to take the first equation and multiply it by -5. So everything, both sides of the equation, I'll multiply by -5. But the one down below, I'm going to multiply by 3. So again, I'm not changing anything with the negative. I don't need to put a negative on this because I already included the negative above. Now you could have also done a +5 here and -3 down below. That would also work. But in this case, it's okay how we did it there. We just need to get one of them positive, one of them negative. So when we add the equations together, we'll get one of the variables to cancel. So this is the reason why we did that. If we would have gone for the y's, you could have done -3 times the first row and a 4 times the bottom row, and that would have given you -12 and +12, and that's what you would have done to eliminate the y's. So it doesn't matter, again, what variable you solve for. You can solve for either x or y. So in this case, eliminating the x's, we do -5 times the first row and a +3 times the second. Here's what that looks like when you multiply it through. Remember, everything gets multiplied, both sides, you have to multiply by -5. So remember, everything gets multiplied by that. We get +55 on that side. Then we get +15x here, plus 9y equals -33. And we're adding these together. Okay, so this, you get these to cancel, so you should get that one of the variables to drop out. Then we have -20 plus 9. We're going to subtract these and take the sign of the larger number. So 20 minus 9 is 11. But since the larger number is negative, we're going to make this negative. For this one, 55 minus 33, we just get 22 by subtracting that. Then we divide by -11. And then we get our first answer, y is equal to -2. Okay, so now we need to find the other answer. Again, you can either use the top equation or the bottom equation. Now, last time I used the top equation. Let's use the bottom one this time. It really doesn't matter which equation you want to choose to put that into. So I put it, either one of these equations will work. Okay, so I'll put -2 into the y there. Again, I could have used the first equation. Doesn't matter. Okay, so now I'm going to solve for x. So just add 6 to both sides, and I get 5x is equal to -5. Divide both sides by 5, and I get x is equal to -1. When I write my answer, I need to put the x value first and then the y value. So I would write my answer as -1 and -2. Okay, now we have one last problem that we'll do here. We'll do this one specifically with the elimination method. Okay, we look again for what variable we can cancel out, and we see if we can find what the least common multiple is for each one. Now for the y's, the least common multiple would be 15 again. It's kind of similar to the problem we just did, but this, we notice that the least common multiple is 6 because 3, that divides evenly into 6. So this is another problem where we only have to multiply one equation by something. So in this case, the top equation, I'm going to leave that alone. Not going to do anything with that one. The bottom one, I'm going to multiply. I need to multiply the bottom one by a -2. I still need to have that be an opposite sign, so that way I can cancel that one out. So I'm still need the negative there, because otherwise I just have 6 and 6, and if I add that together, it doesn't add up to 0. So that's why I'm putting a -2 there. All right, so 6x plus 5y equals 19. I get -6x plus 6y equals -8. And I'm adding all that together. And so I get 11y there. I get 19 minus 8, which is also going to be 11. And then dividing that by both sides by 11, we get y equals 1, which is our first part of our answer. Then you're going to take that and put it into either equation. Looks like there's smaller numbers with the second equation, so I'm going to use this one to plug my answer into, because again, we still have to find the x value. 3x minus 3 equals 4. Okay, we're going to add 3 to both sides. And now this time we get a fraction. Now, just because we get a fraction, it doesn't mean that we did something wrong here. Okay, so for this, it's possible that you may get a fraction for part of your answer, which is what the case is here. It's just that we get 7/3. So the answer, you would write it as 7/3, 1. So it is possible for you to get fractions on some of the answers on these. It doesn't mean you did something wrong. It just might mean that that problem does have a fraction for the answer. So it's okay to have that. And so our answer, 7/3, 1.